We covered this quickly a little while back, but we're going to go into more detail now on oxidation-reduction reactions. We want to determine first which species in a reaction becomes oxidized or reduced. Well, first we have to review the definition again about what's oxidation and reduction. Oxidation is the loss of electrons. So if sodium goes to the sodium ion and gives up an electron, its charge goes from 0 to +1. So the element becomes more positive when it is oxidized. Reduction is when you gain electrons. So if you have magnesium 2+, right over here, gaining 2 electrons to become neutral magnesium, magnesium went from +2 to 0. An element becomes less positive when it is reduced. So that's a good handy way to remember it. Reduce means less, so you get less positive in reduction, and you get more positive in oxidation. Which element became oxidized and which became reduced in the following reaction, where we have potassium chlorate turning into potassium chloride and oxygen? And remember, we don't care about the numbers in front that tell us how many of the molecules we have. We don't need that now. So the first thing, we'll find the oxidation states. We go to the periodic table, and potassium is +1, oxygen is -2, okay, and there's 3 of them. So we have -6 for the oxygen, potassium is +1, so chlorine, this has to balance out to be 0. So 1 minus 6 is a -5, so the chlorine has to be +5. We come over to the right-hand side. Potassium is +1, chlorine is -1. Get that off the periodic table. And then we have oxygen. This is just neutral. So oxygen goes from a -2, that's this blue line here, to 0. So it became more positive, so it must have lost electrons. Oxygen was oxidized. That's handy. Chlorine went from +5 to -1. It became less positive. In fact, it went negative, so it must have gained electrons. Chlorine was reduced, and potassium stayed the same. Which of the following elements is oxidized and which is reduced in the following reaction? First thing we're going to notice is we don't care about the coefficients, so we're just going to blot them out here so we don't worry about them. So please give this a shot on your own, pause the video, and when you're ready, come back, we'll pull out the answer tab. Okay, here's our answer tab. Let's see what we have. Hopefully you got this. Fluorine, they tell you the oxidation state is -1. Chlorine, a diatomic molecule, its oxidation state is 0. It goes over here to chlorine ion, and they tell you it's -1. That's what the negative right there means. And fluorine, of course, is 0. Diatomic, it's 0. Fluorine went from -1 to 0. So that became more positive. Notice it didn't have to be positive, it just had to get more positive. That means electrons were lost, so you have oxidation. Chlorine went from 0 to -1. It became more negative. So electrons were gained, reduction. An oxidant, speaking chemically, is a species that wants to be reduced. So it causes something else to be oxidized, right? These things go hand in hand. Free radical species, like singlet oxygen, that means where you just have one oxygen. See that? That's a free radical singlet oxygen. They're not good. Why? Well, here it is. Here's the Lewis diagram for the singlet oxygen. It wants 2 electrons, and it'll take those electrons from anywhere it can get them. So if it's inside your body, it will take it from other molecules in your body that frankly needed the electrons, and it takes them away, so it can be forming this ion here, this 2-. We're not going to get too much into biology here, frankly, because I'm not a biologist, but the molecules in your body that are doing the work for you, they have the right amount of electrons to do their job. However, when you get these free radical singlets coming around, they steal those electrons, they impact how your body functions. So what's the solution to that? Things that are called antioxidants, like carotenoids, which are found in veggies and carrots and such. They have lots of electrons to lose. Here's the molecule. This is a huge molecule. So it doesn't mind losing 2 electrons here. So this free radical singlet becomes this ion here, and it's all happy now, and it hasn't taken any electrons from parts of your body that needed them. So it helps protect you, and the message is make sure you eat your vegetables.